At this part, we're gonna add a check for skylight, and we're gonna change our crouch idle animation a little bit. So open the Mixamo and search for a crouch pose. Don't forget to upload a character if it's not saved from the last time. And I think that I will use this male crouch pose for an idle pose. Just download it without skin, no keyframe reduction, and everything by default. Now open the Mixama converters that we have downloaded in the first video and copy this animation that you have downloaded into incoming FBX folder. Let's rename it like AS crouch idle v2. Now back and go to outgoing FBX. Also, let's search for a breeze animation. We have a breathing idle. Let's download this one. Also, maybe let's decrease a breathing and sway also, and download it and do the same. Copy this animation into incoming FBX folder. And rename it to AS crouch secondary motion. Now open Mixama converter. Enter the conversion process, and here at the bottom side you will see converted animations, and you will see your two animations. And click here near running woman on click here to convert the animations. Now they are converted and we can find them in outgoing FBX folder. Open your project and navigate to a folder where you have your animations. And drag these two animations here. Select a skeleton for your character and select import all. Now let's open crouch idle and select force root lock. Doing the same for secondary motion. Here in secondary motion, in an additive anim type, select local space, not a skeleton reference pose, selected animation frame, select a crouch idle animation, v2, and save it. Now let's open our animation blueprint and open a place in locomotion for an idle state and replace AS crouch idle with crouch idle v2. From here, apply additive, and into additive animation add secondary motion that we have created. Don't forget to loop this secondary motion. Now plug this apply additive to blend poses by bool true node. Now let's see how it will look like. Let's set an alpha to 0, 1 and not just 1. Maybe a little bit bigger value for alpha. Now we can see that player is moving a little bit, like he's breathing in an idle pose, and that's fine. So this idle animation is much more better. Also, don't forget to change an idle animation in your blend space for walking. Open your blend space crouch walk. And on the left side, for a speed 0, select AS crouch idle v2 instead of AS crouch idle. Next, do the same as for idle, this apply additive, to move forward, but for crouch walk. So open a place where you use your blank space crouch walk and apply additive. Well, here we can also add some check. We can get our speed and check if it is less than, for example, 20. Then select float and plug it into alpha. If it is less than n than 20, we're gonna use 0 to alpha. If not, then we're using 0 alpha, and don't apply an additive to just walking. Well, now when we're finished with an animation, we can close it, and we have to check whether we are under sky. So let's open our darkness detection system, and on trace position, let's set our trace draw debug type to none. And let's create a function, and let's call it is under has roof above. Well, here we're gonna get an input of points around the player. Or even not, we don't have to do it, we're gonna do it from a character location. Let's get a character. Let's get a character mesh. Let's get a mesh socket location. And we are searching for a location of heads, of a head. So we will get the word location of character head. Now let's move this point a little bit upwards. So let's add the vector, add the vector, and we're gonna add something like 100 by the axis. So that start point will be 100 above a head. From this point we're gonna do inline trace. This is gonna be our start point. Also, we have to do it in some small grid around head, because even if a player will stay under something very small, like this, we should not tell that he is under a roof. We should ignore such width of an object. So we'll have to make a grid. And let's do it. This is gonna be our start point. Let's create a local variable and call it local grid x of type integer, and a local grid. Well, it's gonna be a square, so we're gonna call it just local grid size. Now let's add a for loop. Local grid size half. And let's set it to 2 by default. Well, first index is gonna be minus local grid size half. Get it? Multiplied by minus 1 and plug it into first index. And local grid size half into last index. Doing the same, just duplicating it with Ctrl D button and doing the same for each loop every time when we're looping through here. Here is our central location. Well, we have to do a vector. Let's make a vector and let's split this vector. Let's just split this struct pin. So we have to add to x some distance between our grid points. Let's create a local variable and call it local grid cells distance. And let's make it a float. It's gonna be 10. Now let's get it here and multiply it by an index of first loop. And then we're gonna add it to an x of head position. And this is gonna be a new x. We should do the same for y. We're gonna get our local grid cells distance here and multiply it on this index of second loop. Then we're gonna add it to y from head location and plug this into a make vector. Z is gonna stay the same. Compile and save. Now we're gonna do a line trace. This is gonna be a start and end is gonna be a little bit higher. So let's add to this vector another vector that will be higher on maybe 1000 or maybe 2000. And this is gonna be an end vector. Also, let's use not line trace by channel, but let's use our trace position function. So this goes to start, to from, this goes to 2. And we will check whether we have a hit. Let's open trace positions and set draw debug time for 1 frame. And in scan, in scan function, let's add a new sequence node. And we're gonna call has a roof above to see our traces. Now you can see, okay, let's do it a little bit in a different way. Let's open trace positions and let's make draw debug type as an input of a function. And let's set it by default to none. Okay, now in has roof above, let's select draw for duration, compile and save, and start a project. Now you can see how our line traces above our head goes. Maybe I think that we should bring them a little bit closer to a head. So this is how we're gonna check whether there is a roof above us. Let's disable draw debug type, and in this function, at place where we're adding 100 to a z location above head, let's add 30. Compile and save. Now we have to check if every trace had a hit. And if every trace had a hit, that will mean that there is a roof above us. So let's create a local variable and call it has a roof of type boolean, and let's make it true by default. Right here, after trace position, let's break a hit. And we're gonna set has a roof as get set a roof and blocking hit. And we're gonna return this value. So let's add a return node and return yes. Oh, not here. I'm sorry. We should do it when the loop will end. We should do it on completed of a first loop. So navigate to your first for each loop and connect completed to this return node and plug has a roof into yes node. Now let's print some string. Let's select on this boolean and for debug reasons, if it is true, we will print under a roof. And under sky if false. Also, let's change. Oh no, we will not change the color. So now let's print them for 0.7 and let's start. Now it prints us that we are under a sky, still under a sky, and here we're staying under a roof. Also here we're staying under a roof, and now we are under a sky. Well, how we gonna use this? We're gonna use this value to multiply our stealth factor somehow, because as you can see, here, for example, we're not under the sun. Sun distance can be 0. It will mean that it's a very dark area, but it's not because we are under sky and skylight affects us. It's not very precise, by the way, but we have what we have. So now let's open darkness detection and promote this yes to a new variable. Let's call it is under a roof. Well, now let's open our stealth system component. Where is it? And navigate to a function calculate current stealth factor. Here we are calculating it, and what we're gonna do, we're gonna add a new sequence node and disconnect Zen2 and connect this debug value to Zen3. And on Zen2 we're gonna get our darkness detection component, get under a roof, select on this value, and get our current stealth factor and add something to it. We're gonna add different values depending whether we are under a roof or not. So plug this 0 to return value of select. So if we are under a roof, we're adding 0. If we are not under a roof, we're gonna add to 0.2. Also right after that we have to clamp this value between 0 and 1, or 0.1 and 1, and set current stealth factor with this new value and connect it to Zen 3. Now let's check. So here a new minimum value is 0.7 because we're under sky. Now if we will stay somewhere inside instead, we will have 0.5 minimum value. And outside, if we are under sky, we will not be able to reach such value if we are just staying. Okay, I think that I have again have a collision broken for some meshes. Okay, now we're able to count our stealth factor for our character. Now, after adding a logic to compute a stealth factor depending on how dark place in how dark place player is located, we have to use this computation somehow in AI behavior. Let's create a new folder in our stealth system and call it test AI. Here we're gonna open it and create a new blueprint class of type character and call it BP test AI. Open it up, select a skeletal mesh and select a skeletal mesh asset as many. Or anything you want, it doesn't matter. For skeletal mesh, set its location to -90 on the axis and rotation to -90 on the axis. Compile and save. Next, add an AI perception here. Save, compile, select AI perception. And here in senses config, add a new sense. Select AI site config. Open it. Here we can see a site radius, loose site radius, and other values. Main things that we have to do, we have to open a detection by affiliation and select everything here. These flags only used in C++ development. They cannot be used in blueprints for now at least. So to make it work in blueprints, you should select them. If you will not, an AI will not be able to see anyone. Let's set its site radius to 1000, loose site radius to 1200, and peripheral vision to 70 degrees. Save and compile. Now, let's open stealth system folder again and create a new folder. Call it perception. Open it. Here create a new blueprint class of type actor component. Call it BPC custom perception and open it. Open it in full window and create a new function called initialize. Here we're gonna get an owner of a component. So we will get a character that owns this component and cast it at first to a character and promote it to variable. Let's call it character. Right after that, we're gonna get an AI perception component from this character. So get component by class and select AI perception component. Now we have to check if this component is valid. So we will check if we didn't forget to add this component to our character. So let's call is valid utility function with a question mark. Plug this to an execution node. If it is not valid, then we have to print string. And let's print something like AI perception component not added. Let's select a text color as red and duration to 1000. In other case, if it is valid, we have to promote it to a variable. So let's promote it to a variable and call it perception component. and plug it with isValid execution node. Now we have to call this function from event begin play. Let's delete event tick function. Now in initialize function, now let's create a new function and call it stop bindings. Here we're gonna get a perception component and bind event. We have to bind event on target perception updated, connected, drag an event node and type custom create event. We'll use this utility function, and here we have to provide with functions that will be called when on target perception updated is called. Click here and select create a matching function. Unreal will generate us a function. Let's rename it and let's call it on perception updated. Here we have a stimulus. Let's break it. In stimulus we have an age, expiration age, strength, and so on. Let's make a print here. Print and not print string. Let's add a print text. Format text. And this format we gonna write something like percepted braces. Here we're gonna add an actor that we have percepted, then space, and successfully in braces again. Plug an actor in an actor node, an actor pin, and successfully sensed to successfully. Now we have to call setup bindings in event begin play right after initialize. Compile and save. Let's open BP test AI and add this component. BPC custom perception here. Compile and save. Open your level, navigate where our AI is located, and let's add it somewhere on our level. Let's rotate it to face some dark area, so he will look in this direction. And let me move my player start somewhere here, and let's start. Now you can see that in top left corner of my screen it was printed that it successfully percepted my character and false when he ended percepting my character. Well, we cannot change a perception system with our stealth factor, so we have to store every percepted actor here. Let's delete our print. Let's create a new variable and call it base percepted actors of type actor. Here, and it should be a set. Compile and save. Here we have to check whether an actor was successfully sensed. If true, then we're gonna get these base percepted actors and add a new one. And this is gonna be this actor. So just go here and call get actor. This get actor will get this local variable and connect it to a true. In another case, we're gonna get this set in false and call remove, connect it to false, and also get actor. So now we will have a set with all actors that our NPC sees, but we don't have our stealth factor used anywhere. Also, one more thing to add is that our AI perception may have not only AI side config, it may also have hearing config and so on. So we have to define that this only works only for a side. So let's get a stimulus and check if it is Well, how can it be checked? Well, structure cannot be casted, so mm, so to do it, we're gonna get our stimulus and get sense class for stimulus. Now we can check whether this class is equal to site AI sense site. Add a branch here by holding B on your keyboard, and if it is equal, then we are adding or removing our character from this set. If false, we are doing nothing. So now we have percepted actors. Next, we have to create function, and also let's create a new variable and call it validated percepted actors. And let's create a new function and call it update or just validate percepted actors. Here we're gonna use our stealth factor. So now we have to know about stealth factor of any character that AI sees, because not every character may have our stealth system. To do it, let's open our stealth system and create a new interface here. Right click on an empty space, select blueprint. Here select the blueprint interface. Call it BPI stealth factor provider. Open this interface. Name first function as get stealth factor, and it will have an output called stealth factor of type float. Compile, save, and we can close this interface. Now navigate to our character. In my case, it BP thief character. Select the class settings on the top side of the screen. Here you will have an interfaces section, and near implemented interfaces section, select add and add BPI stealth factor provider. Now compile and save, open my blueprint, open interfaces section, and here you will have a get stealth factor function. Open it up. By default, this function returns 0. Let's get our BPC stealth system from our character and get current stealth factor from here and plug it into return node. Compile and save. Now we can close our character. Navigate back to BPC custom perception to validate percepted actors function. Here we're gonna get our base percepted actors, and we have to make an array from them. Cast it to array and add for each loop. Now, for each of the actors, we're gonna check if they implement this interface. Does implement interface, and interface is gonna be BPI stealth factor provider. Add a branch. And let's create a local variable, and let's call it percepted actors with a local keyword at the beginning of a variable name. So it will be called local percepted actors. Now, if our actors that we have percepted doesn't implement such interface, then we're just adding it to this set. Now, if true, then we're gonna get this actor and get stealth factor. It will give us a current stealth factor of an actor that we have percepted. Well, we have to multiply it by some value. And this value is gonna be our stimulus. Like in a test AI, we have a config for AI site, and here we have a site radius. It is 1000. And now, if a character stealth factor, for example, is 0.5, then site radius should be 500. So we have to get this site radius. I'm not sure that we can get it somehow in a blueprint. So let's create a new variable here in this component and call it base site radius of type float. Make it a single object, and by default it's gonna be 0. Or maybe let's make it 1000 by default. Okay, now let's get this base site radius and multiply it on our stealth factor. This is gonna be a distance at which an owner of this AI perception should see our player. So we're gonna get a character that owns this component custom perception and count its distance. We're gonna get it first, we're gonna get its location, get actor location. And second, we're gonna get a location of a percepted actor. So let's get it here and get actor location. Now let's count the distance between these actors. Now if this distance is less than or equal than a needed distance, let's add a branch, then this actor is truly should be percepted, even if he is hiding. So we're gonna get our local percepted actors set and add a new value here. And the value is gonna be this actor. If false, then we're just not adding it here. Well, before we are doing everything here, we have to clear a previous base percepted, not base, but validated percepted actors. Let's move it a little bit and get validated percepted actors here and call clear. Plug it somewhere here. Compile, save. Well, now let's open our begin play. And here, after setup bindings, we're gonna set timer by function. We're gonna do a check every 0.3 seconds. And the function name is gonna be validate percepted actors. Function name is gonna be validate percepted actors and make it a looping timer. So now we will have an updated set of actors that our AI is really percepting. So let's check it now. Let's first open our test AI, and we have already added this component here. So now let's open onPerception updated function. And after a true branch here, let's call print string and name it saw a player. And let's test it. Now let's see at which distance this AI will see us. I'm gonna start from a third square here and go through this shadow, even in control. Okay, he saw us. Let me move a little bit back. I didn't mention at which square he saw us. He saw us almost in the middle. right here. So now let's delete the print from here. Open validate percepted actors. And by the way, maybe that's overcomplicated by the way, so no, that's fine. So now here, right after adding something to array, we're gonna do the same print, just paste it here and plug it here. So now we will see when he will see us with our stealth factor. Let's move on the control. Previously, he already saw us here, but now as you can see, print is not printed. Let's move closer. And he saw us here at this place because of our stealth. Let's move away. And now I'm gonna move with without crouching, and he saw us here. So that's how this system works. It's only done with the test AI, and you should. It's only way to show you how a logic of a stealth should work, and you have to change or implement it or add more functionality depending on your needs. I think that at this part stealth system can be ended. Let's test it with a bush, for example. Let's move our NPC here, and he sees us right here with 1 when I'm in the middle of a bush. And if I will walk in control, he doesn't. Okay, he saw us. Okay, without crouching in the bush, he saw us from here. And if I will sit down, as you can see, he doesn't see us. Nothing is printed. And I have to move a little bit closer in the bush. And only now he starts to see us. All the values can be adjusted to fit your needs. That depends on you. And thanks for watching this series of tutorials. Hope it will help you